Okay. So, good morning, participants, industry experts, and our customers. We welcome you all to the webinar on enabling process research with customized skid plants. This is designed specifically for researchers from oil and gas, chemical, pharma, and some research laboratories. We would like to thank you all for taking your precious time to attend this live webinar today. In this webinar, we will hear from experts and our esteemed customers who are also joining this webinar. The webinar is focused on the basics of research-related skills, pain points of the users, and the case studies of real implementations. One interesting highlight of this session is the smart or IoT-powered skid systems to enable better research and data analytics.
We move to the next segment of our webinar. We want to express our appreciation for your time and attention. Thank you once again. I ask now Mr. Milind to take you through the next phase of the webinar.
Yeah. Thank you, Dhanajay, for helping users understand the background of the organization and its credibility, especially into the scale plans. With this, now I request Rohit Shinde. I would like to introduce Mr. Rohit Shinde. Rohit is our next speaker. Rohit has completed his MTech from ICT Mumbai, which is the premier institute in the subject matter. He comes with over 10 plus years of experience working in the field of skid plants, solvent extraction, distillation, marine desalination, and condensation systems. He heads the process design and development at Instron Technologies. I'm sure these credentials are interesting enough for you all to listen to Rohit. Over to you, Rohit. Please take us all through your session.
Yeah. Thank you, Milind, for the introduction. Good morning to everyone. Before we start the presentation, I would like to ask a question that have you worked on any pilot plant, skid plant, or R&D research project? So let us know and kindly comment in the chat box. We will revert you regarding this. So in this presentation, we will focus on need of a skid plant. What are the skid plants? What is the need of skid plant? And we will cover the framework from R&D to production, why to conduct the skid plant studies, advantages and benefits of skid plants, its application, what are the ongoing skid research projects we are delivering. Next thing, before construction any pilot plant or skid plant, what are our approach or steps we take, and wide experience regarding the skid plants. So today we live in a dynamic and turbulent global community. For any organization to survive in this environment, the R&D is very much necessary, and R&D is also become a contributor in a global economic growth. Government of India is also promoting companies or supporting the companies through Make in India and IDEX programs like IDEX such as. So any journey of a production plant starts with the R&D, and the skid mounted plants makes the represents a bridge between R&D and production. Okay, so this journey can be divided into 3 phases. First phase is a bench scale, second is a skid mounted scale, and third one is a commercial scale. The bench scale refers to the testing of materials. Basically, it is just a laboratory kind of work where all the researchers do their analysis and research and analysis work. In commercial plant, it is permanent upsizing of a process which can be operated in a batch or continuous mode. But in between these two, we can't directly jump from bench scale to commercial scale. There is one step that is commercial mounted scale phase, where we can use or we can study the feasibility, time, cost, scaling factors, unpredictable results, and further development of a process. Further going deep in the phases, in the bench scale, the material handling capacity is very less. It is in a few grams to several hundred grams. The objective of the bench scale is to study and to get the desired yield and to check the safety of a process. The quality and efficiency are usually not concerned in this phase. Whereas in the skid mounted scale, the material handling capacity is in between 100 grams to few kilograms. We can opt skid mounted scale. It can be used to optimize the process parameters like temperature, pressure, etc. And it can be also integrated with process operation, which are available in large scale, commercial scale. And commercial scale phase, it totally depend on the product, market size, and economics. So let us see why to conduct the skid plant studies. A skid plant allows investigation of product and process on an intermediate scale before large amount of money that are committed to full scale production. It is very difficult to predict the effect of direct effect of R&D to effect of increase in scale from directly R&D to production. So this is the one of the reason. And third one is that it is very difficult to design the large scale process plant from laboratory scale. I hope you have got my point. As we discussed, there are many advantages and benefits of skid mounted plants. It enhances the learning and innovation. It develops the new process technologies. It is used to optimize manufacturing process for efficiency and cost effectiveness. It will reduce the risk and cost. It is also used to validate models, and it can be used to generate a lot of data. And it is used to check the demonstrate feasibility and performance of the process. So there are various applications where we can use the skid mounted plant in various sectors like pharmaceutical sector, biotechnology sector. It is used to develop the new medicine or molecule in the pharmaceutical or biotechnology sector. In chemical and food industry, skid mounted projects will be used to develop new products. In petroleum industry, it can be used to refine and various petroleum products. In metal, it is used in extraction and purification of metals from ores. And in environmental remediation, it can use to treat the water with new technologies. So before construction of any skid mounted plant, we follow the 3-step approach. That is basic engineering, detail engineering, and project implementation. Before start of a basic engineering, we interact with the client and we understand their requirement, and we gather the basic data from the client, and we do the basic engineering. What is included in that? We develop the PFDs, PNIDs. PNIDs included with equipment, walls, instrumentation, and basic process control. We freeze the basic equipment specification. We conduct review meetings with the clients, and at the end of the basic engineering, we can predict the construction cost of a skid mounted plant, which is up to plus minus 20%. Then we move to the next step, that is detail engineering step. In detail engineering, we finalize the PNID, we finalize the equipment specification, instrument specification, the scope of work, layouts, 3D models, and all of the things. And at the end of detail engineering, you can get the construction cost, which is up to plus minus 5%. And at the last, in the project implementation, we order the equipments and install at our site, and same can be commissioned at the customer site also. That is factory acceptance test and site acceptance test. So we have wide experience regarding the pilot plant that will be explained by my colleague. That's it from my side. Over to you, Milind.
Yes, thank you, Rohit, for helping our users to understand the basics of skids, especially the difference between the skid plants and the full-scale plants. And I guess this is very well understood by all the users. Looking at the list of the users and the geographies, I think we have a good amount of good number of participants, and they are from almost all the areas like in India as well as international. So happy to see that this webinar is this news had gone to many users across, and many people are attending it. So moving on to the next session, I would like to introduce our next speaker, Mr. Rahul Bhokare. Rahul is an alumni of MIT Pune. He comes with 2 decades of experience working in India as well as Middle East in the field of pilot plants, field study, HAZOP, catalyst research plants. He is a co-founder at Instron Technologies and heads the process plant business vertical. Now I request Rahul to take us all through the state-of-the-art skid systems along with some case studies. Over to you, Rahul.
Thank you, Milind, for introduction. My colleague Rohit has explained you about the need and basics of the skid-mounted plants, which are backbone of R&D basically. So with this three-phase approach, which has been used by Instron, which plays a vital role in the R&Ds and to gain experience, rich experience in supplying various kind of units basically. So with this approach, we got a wide experience in various fields, and we could able to work from various process parameters, such as from full vacuum to high pressure up to 250 bar gauge. Again, for the temperature, in some cases, it was required to operate at -30°C and as high as 900°C. Also, the capacities are different with respect to the requirement. So we work in some milliliters capacity to as high as some liters per hour or some KL capacities also. And as this wide experience helps us to work on various chemicals and raw materials, hazardous raw materials also, such as TiCl4, some potent drugs. And with all these, as the customization required, we supplied the plant to meet the customer's needs basically. And the main important thing while working on such a skid mounted plants is we should, the main challenges are the selection of reliable and accurate instruments. And our experience leads us to select the correct models or correct instruments, so which help us to collect accurate data for the research or scientist. And also another thing is in commercial plants, normally the operating people are trained people. However, in such a lab scale or skid mounted plants, the operators are the scientists or maybe the developers. So in that case, the HAZOP is one of the important thing. So accordingly, we take care of all the safety factors while designing such kind of units. So I'll take you through the few completed projects. You can see the couple of projects shown on the slide, where the first one we have worked for the DRDO, where we supplied the unit for the vehicle exhaust condensation system, where we design and supplied the system for the condensation of water from the exhaust gases. And we got a good results, and DRDO is working on that again. And another plant you can just see, which we supplied overseas, which was a distillation plant, which we use as a multi-purpose pilot plant, where we have given the flexibility to operate a plant either in batch as well as in continuous mode. However, there was a facility to operate a plant with various from full vacuum to the as high temperature as 350°C. So, and another projects where we work on herbal extraction plant, which was used to manufacture potent drug. And again, because of our smart capability and very well designed understanding, the plant the client was used this plant for the multiple applications also. And another project which we work with BRC for radiopharmaceutical drugs, which was capacity of 2 ml capacity only. So this a plant which we use for the potent drug was designed for only one product. However, our wide and rich experience of our team and clients helps, we could again design the plant in such a way that they could able to produce 4 more products along with the one which we designed. So because of our smart system approach, where the client was able to produce 4 products from that. However, this smart system approach help us, all the scientists or all the research people, to collect all the data in the required format. The data collection is done in such a way that all these parameters collected and in the form of Excel format, so clients or maybe scientists can use for the analysis, betterment of analysis. They can save their time also. This is the beauty of the smart system. And you can just see on the screen that there is some SCADA system, some KPIs has been shown, and also there is some reports, analysis, and along with the as a part of smart system, we provide IoT-based or solutions where the client are getting some during the operation. They can use it for getting some push notifications if there are some parameters are going out of the range, kind of things. And again, you can get on the shelf access anywhere, even though you're in a meeting. These are the use of the smart system. After covering all these things, completed projects and requirement of smart system, I'll take you to the ongoing projects, which might be quite interesting to all of you. So currently we are working on various skid mounted projects, and few of them has been highlighted here for just understanding and understanding. So here, the first one which we are working on, marine desalinator, which is used to convert from seawater to drinking water. This project has been awarded by TDF, Technology Development Fund Scheme, and we are working for the Indian Navy. This is the specialized product, which there is only one manufacturer all over the world. However, he was not able to meet the Navy's requirement. So under Make in India initiative, we got this project and we're working on it currently. We are at the last stage, TRL 7 stage of the product. And however, we have already filed a patent for the desalination process. And our motto to take it to forward for the community. So where the people are drinking high salinity water, such as area Rajasthan or maybe the remote places, where our plan is to have standard modules which can be implemented or installed at such places, so that everyone can get a benefit from this technology. Another project which we are working on smoke shells. Again, we got this project under IDEX initiative, indigenization initiative through Atmanirbhar Bharat, where we are working for the development. We are developing the process for smoke shells composition along with the filling of the smoke shells. Again, this is the imported one. Only one country is importing all over, exporting it all over the world, and we are at the middle of the project. And soon we are expecting to go to next stage basically. And I'm really happy to inform you that last week we have been awarded with one more project which is prestigious for Instron from the ISRO. The project is basically for the skid mounted plant for the rocket fuel production. Generally, all you might be aware that India has been successfully launched Chandrayaan-3 and many satellites have been launched by India. However, the fuel required to launch the satellites is important, and the technology has been this is not the indigenous technology. So the ISRO has developed one lab scale unit in ml capacity for the production of this kind of fuel. And we got an opportunity to supply the skid mounted unit for liter per hour capacity, and they targeted to go for tons per day, and again they are planning to export it to other countries. And again, another project which is under green initiative, you might be using all the vehicles you are seeing, two-wheelers or four-wheelers, as a battery operated vehicles to reduce the emissions to the environment. And last month we got a project for the engineering of one of the unit from Middle East University for the battery recycling unit, where most of you might be aware that in battery there are noble metals has been used, and again, if you are able to recycle those metals, it will be good for the environment. So considering that aspect, many universities, many research laboratories are working on this uh, principle of recycling. They are finding some ways actually. And here we are working on that project, and we are happy to say that we're about to complete the engineering, and we are next couple of months we'll supply the unit for that purpose. And another project with respect to oil and gas is it is important to measure the steam quality in the oil rigs, and we have developed the process by using the process calculation, proper selection of instruments, and using our automation expertise. We have developed the process, and the system is ready at our factory, and soon we are going to deliver and install at the site to check the steam quality. Again, that will be one of the value addition from our side. And again, this will be soon we are going to have patent on this technology. And after seeing all these initiatives from the government, and again green initiatives and steam requirement for the real oil and gas processes, everyone is listening about the decarbonization. As under decarbonization, everyone would like to reduce carbon emission in the environment. All the industries are looking forward to reduce the carbon emissions to get carbon credits in US, and those countries are talking with that respect. However, we are working on couple of industries, on couple of projects, such as for using of solar energy to generate hot water, which can be used for the process heating in some case, and in pharmaceutical we can use for the some reactions also. But there are big reactors used in the pharmaceutical. So the purpose of using this solar energy, ultimately hot water, is to reduce electricity consumption as well as fuel consumption, which is going to ultimately help to reduce the carbon emission to the environment. So I think, yes, with this, you might have got the importance of the skid mounted units. And I'll ask just Milind to take it to next stage of the.
Yes, thank you, Rahul, for helping our users understand the wide experience and the specifications of the skid plans that you have worked on, and how your organization has helped customers through some relevant case studies that you shared. Now, turning to the next session, before that, what I see is some of the members have joined from the open link shared on the social media. For us to share this recording and also the interesting highlights, I request these members to share their email IDs on the chat box. This will benefit you to achieve, receive the updates from this session. Now, moving to the next section, which is the most interesting section, and one of the attendees also wanted to listen to this expert. This webinar is being attended by a research scientist who's sharing his experience on working on the research skills. I would like to introduce our esteemed speaker, Dr. Deoras Prabhuwaradkar. He has joined from Saudi Arabia, from King Abdullah University, and we are having one of the experts giving this talk from the international location. He has completed his master's and PhD from IIT Bombay and the postdoc from Purdue University. He comes with over 1 decade of experience in esteemed research organizations like General Electric. Now he is the research scientist at King Abdullah University, Saudi Arabia, and he leads the cryogenic carbon capture research program. He is one of the who is responsible for research and taking this research to the market with the help of demonstration units, which is nothing but the skid plants. Now I would like to request Dr. Deoras to share his experience on the skid plants. Over to you, Deoras.
Thank you, Milind, for this great introduction and your kind words. Good morning again to all participants. As Milind pointed out, I have been in the industry for most of the last decade. Right now I'm speaking from a university in the Middle East. One of the reasons I moved from the industry back to the university is because there is a growing emphasis in the universities right now to take the research into field, to show the impact, turn it into products, commercialize them. And this was one of the reasons when I was working in the Middle East as part of General Electric. Most of the projects that we worked on, we had some way or the other a collaboration with the King Abdullah University of Science and Technology. So I moved here about 3 years ago and started working on some of the projects that were at that time in their nascent stages, in the lab scale. As one of the speakers rightly shown the 3 stages of how to take the research to the market. There is a bench scale. So most of these projects were at the bench scale, and I'll probably show some of the, or at least a couple of projects that we have taken from the bench to the field and ready to commercialize. So if you can get to the next, next screen, thanks. So a little bit about KAUST. This is a new university. It's established in 2009. It's a graduate research university, which means we don't have a bachelor's program. We have a master's and a PhD program, and we have also postdoctoral fellowships. So that really forms our research, the base of our innovation and research through the master's, PhD students, and the postdoctoral researchers. Us as research scientists and the faculty members take charge of the academic and the research operations here in the university. The research is predominantly driven from the internal funding that we have here for the initial stages of the research, and eventually taken to the industry, and we have industrial fundings as the research translates into higher TRLs. We have about 120 nationalities on the campus. We have a magnificent campus sitting at the coast of the Red Sea, what you can see at the top of this slide, which is just at the back of my office here where I'm sitting. We have about 12 research centers, 12 core labs, and 3 academic divisions. So the research centers are very much focused on different themes. I belong to the Clean Combustion Research Center, which is focused on reducing the emissions and impact of the combustion processes and the fuels that are used in these processes. We have about more than 26,000 publications, 1,000 granted patents, half of them being the US granted patents, and about 151 startups. So all that in about 14 years, which I'm really proud of being part of this organization. So we are really focused on the research, innovation, and commercialization. So if you move on, when we started in 2009, we were heavily engaged with Saudi Aramco, which is one of the biggest companies in the world. And this was one of our major partners. We are also co-located at KAUST with the research and development organizations of some of the biggest organizations in the kingdom, mainly Saudi Aramco, SABIC, Aqua Power, and so on. So we have a really good opportunity to interact with them in the same campus. So we had been always interfacing with the industry to understand their needs and how we can cater our research towards solving some of the real problems and challenges that various industries face. So having worked through some of the fundamental research, growing it to a level where we can actually take it to the industry in 2023, we started our new strategy, which is called the Accelerating Impact. And the idea of Accelerating Impact was to align ourselves with the vision, Saudi Arabia's Vision 2030, and its research, development and innovation pillars, which you can see actually on this slide. Health and wellness, energy and industrial leadership, sustainable environment and essential needs, and economies of the future. And I've listed a few projects or a few themes that are currently being bucketized into these pillars, which were the existing projects. But we are working and we are growing and adding more and more themes and research areas as we move forward. My research fundamentally falls into the sustainable environment and the energy and industrial leadership verticals. So that's pretty much what my team or my group works on. However, we have a lot of emphasis and work happening in the area of health and wellness and the economies of future, which is mainly into robotics and artificial intelligence. So if you move on, the next one. So here is I just brought two of the projects that I managed here, or rather managing one of them and partly managing the other. So we have developed two state-of-the-art technologies at the industrial pilot scale. And the image on the left is actually, if you see the center of the image, there are two shipping containers that you can see. Those contain one of our ultrasonically enhanced oxidative desulfurization skid, which is about 10 ton per day skid that has been currently installed at a refinery at the south of Jeddah. We are about 100 kilometers from Jeddah, and we've been blessed to have industrial sites mostly on a driving distance around us. That gives us an opportunity to take the take our projects immediately to our customers. So here is one customer, which is again partly owned by Saudi Aramco, and we are right now looking at desulfurizing heavy fuel oil. Right, so we take the heavy fuel oil, which is essentially a heavy product or a heavy outcome of the petroleum or the crude oil distillation process, and we take that and we reduce the sulfur from it, right? So that's the project on the left, which we call as the pre-combustion, which means you clean up the fuel before you burn it. The project on the right is another interesting project, as Milind mentioned. That's the cryogenic carbon capture unit. And we don't necessarily limit it to only CO2 capture. We are also trying to see if we can do right now working on extending it to capturing multiple pollutants. So that particular skid right now, as you can see, is mounted on a trailer. So the idea of both these projects or both these skids is to be able to have them mobile. So one of them is in a shipping container, the other has been mounted on a trailer, so that they can be easily taken to any site where we can get them tested, right? So both of them are right now at a stage where we are testing them. All of them have been commissioned, and the tests are ongoing as we speak. So if you move on to the next slide. I think I heard a couple of speakers talk about TRL, right? So that's basically the guideline that we use in terms of where and how we scale up from a lab scale, an idea to a product, right? So technology readiness level is what the TRL means. We start with TRL 1 and 2, really the one where you get the eureka moment, the idea. That's where you start working on the proof of concept, right? Only the fundamental process, the fundamental key process that you're working on, that's something that you would try to validate at the lab scale. That's going to be the TRL3, and the TRL4 to 6 is where you start going out of the lab into the or bench scale to a lab scale, looking at perhaps the first opportunity to build a pilot plant. This is exactly where we start developing the full system, right? And then you take the full system, you turn it into a prototype, you then take it to a field. That's your TRL 6-7, and then you actually test it in the industrial setup, which is what you saw in the previous slide. The two setups are actually plugged in at the industrial site, and that's where you validate some of your core technical assumptions outside the lab's environment, and also economics. So techno-economics is another key piece for the technology to be taken from the lab to the field, especially if you want to commercialize it, turn it into product. You want to make sure that it's commercially viable, right? So that is where you would also get the opportunity to understand what's your entire system looks like with all your auxiliaries, the installation costs, and so on and so forth. And that gives you an idea of understanding and scaling up your model for techno-economics and validating them, right? So if we move on to the next one, here is an example. So the heavy fuel oil desulfurization project that I talked about, we started in 2018 with the basic science grant that you can see as the lab scale or the benchtop setup that you see, where we were just trying to ultrasonically have the heavy fuel oil and our oxidant and the catalyst react and see what kind of reaction we get. Do we get enough oxidation of the sulfur containing molecules so that they can be removed? And then we move on. Once that was validated, we then started going from a batch to a flow system. This is where the COWS technology translation grant came in handy. So we have different grants at COWS which actually help at different levels of TRL. So starting with the basic science grant, then going to the technology translation grant. We validated the system in a small skid at a 1 ton per day system, and then we built with the help of our industrial partners an external grant. We built the demonstration scale unit, which is the image that you saw a couple of slides ago. So this is the other view of that. And we are at this stage where we are right now aiming after the demonstration to start working on the front-end engineering design of a 1,000 tons per day system, which is going to be a modular scale-up of this. And then about 2026 is where we plan to finish the front-end engineering design, the detail engineering design, and then look for the EPC to start. So that's the timeline for that project. I did not include the cryogenic carbon capture in that example, but the cryogenic carbon capture has had a similar trajectory. We have worked on the fundamental process of the cryogenically freezing carbon dioxide from the flue gases at the lab scale, then developing a very small flow loop in the lab with a small cryochiller, and then we have built the full system on the rig. And we have done some process optimizations on the large scale rig, which is the demonstration rig. The demonstration rig that you saw on the trailer is actually of the order of 1 ton per day CO2 capture. And then the one that we are right now looking at is the demonstration, the industrial demonstration rig that we are trying to build up at a facility in Neom, about 700 kilometers north of where we are. Is for a 30 tons per day CO2 capture. So that's going to be the next, or the industrial scale or the EPC scale that we will be validating our technology at. So now if you move on to the next one, how we do it, right? So as I said, the research, the university research has changed over the years, right? In terms of there is a more and more need for the research to be taken to the field. In the hands of the customers, they validate it, then you iterate and so on. So we have taken this approach of, in my group, what's called as fast works, where we start with basically what's the problem. You first have your problem statement well defined, engage your partner, engage your customer, what's your value proposition, and you develop some solutions, but the solutions are always developed based on certain assumptions. We call them the leap of faith, right? So you make some certain assumptions, you validate them. In order to validate them, you make your minimum viable product or a minimum viable analysis. This is where actually the skid development comes handy. You need to have a skid which is really flexible, which has the capability to iterate these MVPs, MVAs. You learn from there, and then based on that, you either pivot or you persevere. So you continue along the same path or you make changes. Most of the time in the early stages, you would always pivot. You will always find something that partly worked and you always want to optimize. So then the persevere is where you start actually doing the optimization. Pivot is where you start looking at alternate approaches and so on. So this is where in a continuous loop can actually accelerate your approach to the customer, to the market, from the idea, instead of trying everything in the first go. So you start something, take your assumptions, prioritize them, start validating them. That's what FastWorks is, and this is what is really helping us meet this accelerating impact. The strategy that's been launched at KAUST. So if you move on, and this is perhaps my last slide, brings us to the what we look for in pilot skid requirements. So most of the projects that I worked on, at least the last two, what we have seen is it's a single integrated system. It's a combination of a custom built system that is perhaps the one that is scaled up from our lab scale testing. And then you have or idea, and then you have some standard pieces of equipment. But a skid is essentially a single integrated system. We prefer to have centralized controls and utility supply so that it can be easily plugged in. Whenever you go to a site, you just plug it to one. Let's say you have water, air, nitrogen, electrical. You just have one time point, and that's where you source all your utilities. That makes life much easier. We need to be flexible in order to accommodate the future changes and iterations, so that you can keep doing the fast works loop that I was talking about. I think one of the speakers mentioned about the has of and has it, and that's indeed very important, because when we take something out of the lab and we start building it into a system, many times in the lab scale, working under fume hoods, for example, in small quantities, you don't really realize what could be the real risks of taking something, especially in the chemical industry or process industry. You don't know how the risks would scale up. So risk identification, mitigation becomes a key. And I think when you build your first pilot skid, most of the risks really get identified and mitigated. So that's another important role that a pilot skid plays. It also acts, as I said, as a first validation of a full PNID, and it gives you the segue for your techno-economic assessment. All of that is possible for us when we have an engineering, design, and development partner with the right technical background, right? Because if you don't have that, people coming from the research background, they do not necessarily have all the expertise that is needed to turn their idea into a skid, right? And that is where we start increasing the risk on the project and slowing down the deployment. But you have the right partner, you can actually reduce the risk, and you can accelerate the deployment. I want to take a moment here, and I'm going to really congratulate Instron team, because they have been this partner for us in this journey. At least we've started working on one of the projects that's really the next pilot skid that's going from the lab to the market, and I'm glad that we have joined hands with Instron for that. So with that, over to you, Milind.
So thank you, Deoras, for the nice words, and most importantly, for sharing your practical experience with the scale systems. and the benefits you achieved through it to achieve your technology commercialization objectives. I'm sure now the users can understand the actual world implementations of such systems. Now, having come to the end of our first section in which the speakers were talking, industry experts and our experts were talking, and they have shared their insights on meeting the customers' needs, specifically what type of plants at different stages of technology development, the need of the scale plants, spatial range of sensors and systems used for such evaluations, capabilities of Instron technologies in the subject matter, the expertise, environment, and opportunities which are available at King Abdullah University, both for the research as well as the academics. And the most important thing that I liked about how the TRL level, the technology readiness level example that you explained, to link it from an idea to skilled to the market journey. So I think those were my personal takeaways. And with this, now let's move on to the next section. Just a reminder, our admin has posted a feedback form. And if you spend a minute to respond a few questions, that will be really helpful for us to improve on the content for our next research related webinar, and also to attend to any of your specific requests. Now, let's move to the next section where all our attendees get a time to talk with our experts through this question and answer session. So now, till the time you all make your questions ready, I'll ask some of the questions that we have received in the chat box so far. I think the first question can be directed to Rahul Bhokare. Rahul, there is a question, how this research skills can be used to try multiple recipes?
Yes, see, research plants are basically designed based on the requirements. As Deoras sir already explained, these are the customized reads basically. So even though those are designed for your specific application, and if you could able to explain your other needs or maybe additional applications, it can be redesigned, or maybe there few things can be added to it, few instruments, and definitely you can make it as a multi-purpose plant.
Okay, thanks, Rahul. I hope this answers the question of one of the speaker. Maybe you can ask a follow-up question. Are there any speakers? Are there any attendees who want to answer? They can unmute themselves and ask the question. Yeah. Any of the participants want to ask a direct question? I think at the start of the session, one of the participants explained about carbon capture related. Yeah, Uday.
Yeah, thank you. Thank you for organizing such kind of a meeting. And this is the first time I'm getting more about Instron. This to the doctor who have already worked on the project on carbon capturing. In Indian context, is it commercially viable? That's a very simple and layman question I'm just asking on that for any CBG project.
Yeah, I think, yeah, Dr. Deoras can answer that. Yeah.
Yeah.
So I mean, it's not a question that a researcher should answer. Perhaps a policymaker should, because the whole economics of CO2 capture or the other decarbonization technologies, the viability really comes from what kind of policies, incentives, penalties you have in the system, right? The other opportunity is, do we have utilization or what we call as a circular carbon economy in the system to cover the cost of CO2 capture. And I want to give example of our project that we are right now building in NEOM. So we are going to be capturing CO2 from a gas turbine combined cycle plant from the exhaust of it. And the CO2 that is captured in that system will be used by Saudi Aramco to turn it into e-fuel. So we'll be sending it for the methanol to a methanol synthesis plant up at NEOM, and then it will be eventually turned from methanol to gasoline. So now if you see this in this whole value chain, we are able to recover the cost of CO2, right? I don't have the details of the economics, but this is what actually makes our CO2 capture viable. So I think it is highly geography dependent in terms of what market you have for the CO2 capture. As such, CO2 capture, if it is, I mean, I've heard stories where people are saying that I would rather be paying penalties than, putting down the cost for CO2 capture. And that is where the whole idea of CO2 capture starts becoming, commercially not viable. So I think it is extremely case to case dependent. If you look at the technology spectrum, and if you're looking at what technology is cheaper, there are multiple studies that have been there in the open literature, which talks about absorption-based systems, membranes, and cryogenics. And so far, we have seen that cryogenics, when it comes to the energy penalty, which is one of the biggest driving parameter for a CO2 capture technology, cryogenic turns out to be the lowest in terms of the energy penalty. So if you are interested in knowing more about our technology, Instron has my contact details. We can certainly talk offline about it. But to answer again your question, summarizing, highly case dependent, policy dependent.
Thank you, Doctor. Because you know that investor looks for an ROI. If that is justified, everything goes well. And
Exactly.
as of now, yeah, and methanol, when we calculate, it comes out 25 to 35 rupees. And establishing this plan, carbon capturing, it is not viable as of now. But
Yes.
even though methanol is there, but the production cost is going to be very high when we establish. But further, any valuation can be added, and capex is going to be recovered in 5 years or something. It's going to be viable, because there is a huge opportunities happening in India. A lot of CBG plants going to come up. If some cost effective capex is going to be deployed, and we can recover it. Nothing like that.
Right.
Thank you, Doctor.
So,
I think I'm just thank you back, and I'll be in touch with you.
Thank you.
Yeah.
Yeah, that was really an interesting interaction. So thank you, Uday sir, for asking this interesting question, and thank you, Deoras, for answering it in a nice way. I think there are plenty of examples wherein initially the cost of such technologies are beyond the industry's return on investment brackets. But over a period of time, and because of the policies, I think that's what Deoras was trying to emphasize. It is how the seeds are implanted, and then when it grows, you will see definitely a better return on investment as the applications come up. Okay. So are there any other questions? Any of the attendees want to ask any questions to any of the experts? I think there is one question in the chat box. I think, can you give an example of highest temperature application reactor that you have delivered? Rohit, would you like to answer this question?
Yes. We have delivered one reactor for the naphtha reformer, and the reactor temperature was 900 degrees Celsius. And as you know, the SS316, or stainless steel, can't handle the temperature more than 600 degrees Celsius. The reactor was developed, material construction of a reactor was in colloy. And the reactor was designed using the API code. I hope that is the maximum temperature we have handled.
Yeah. Yes, I hope this answers the question. If there are any details that you want to ask, you can reach out to us. You can type those things in your chat box. Uh, uh, are there any further questions to any of the attendees? So I assume there are no further questions at this point of time, but if you have any of the follow-up questions, you can reach out to us on the email addresses and contact details mentioned here. We have a presence, physical presence of our company in Pune, in India, in Mumbai, again in India, and we also have a presence in Canada. And as explained earlier, we have many successful installations. Our customers spread across the world, almost in all the geographies. And we'll be really happy to link our basic core value of innovate to improvise to meet any of your requirements of the skilled plans or any of the needs that you have. He comes with a 20 plus years of experience in handling key accounts, developing channel partners, business development. He has worked with MNCs like LAP, Belden, Leone Cables. He now heads our India business development at Instron Technologies and interacts with the customers like you all to understand the needs to offer them innovative solutions. I request Dhanajay to take us through the background of this organization and highlight why users should listen to these experts. Over to you, Dhanajay.
My name is Dhanajay, and I will be taking you through our company's profile, strength, and reach experience in the industry. Let us start by looking at who we are. We are one team who has trusted name in industry, celebrating a remarkable 10-year journey. Instron Technologies started with a vision to deliver ROI-based solutions to mission-critical applications. Our motto, "Let's grow together," reflects our commitment towards collaborative working and progress. Over the years, we have delivered cutting-edge solutions, adapting to the changing needs of our esteemed clients. That's why we are known for our specialized innovative solutions. Now, let us get a closer look at our company through a corporate video.
We at Instron Technologies deliver our products and solutions for domestic and international customers, for manufacturing industry, for process industry, and also research laboratories. And we could do this because of our in-house cross-domain expertise, rich experience, and dynamic team.
Hello, I'm Milind Saindane. Hi, I am Rahul.
Hi,
My name is Rahul.
I have 19 plus years of experience in research, new product development, and Internet of Things.
I have more than 2 decades of experience in process engineering, automation solutions, and new product development. With me, I bring 13 years of experience in automation and IoT new product development.
Instron was incorporated as a proprietor firm in 2013 and Instron Technologies LLP was formed in 2016. Based out of Industrial Hub, Maharashtra. We have served 200 plus repeated clientele and now we have incorporated Instron Technologies in Canada to serve the North American market. This makes us MNC with Indian origin.
Instron Technologies offers products and solutions into 3 verticals: process plants, digital factory solutions, and test bench systems.
In process plants, we help customers right from conceptualization to detailed engineering and also complete plant supply and installation. In digital factory solutions, we help customers monitor their critical parameters on the go by offering systems right from sensors, communication with existing PLCs, and then giving authenticate data to empower the decision makers. And in test bench systems, we provide end-of-line and performance evaluation test benches for, say, electrical motors, appliances like refrigerators and ACs and thrusters, etc. Our strength is our in-house expertise in automation, IT, chemical processes, and mechanical design. We leverage it to discover unmet customer needs and provide turnkey tailor-made solutions. Our solutions have helped clients to enhance their production and efficiency to achieve their sustainability goals. Our mission at Instron Technologies is to continuously innovate and enhance operations for customers globally in the manufacturing industry, process industry, and research laboratories. Our vision is to become a recognized leader in specialized products and solutions, particularly in process plant systems, digital factory solutions, and test bench systems. We aspire to make substantial contributions to enhance productivity and efficiency for our customers. We have been recognized as one of the 10 most promising industrial IoT solution providers. We are ISO certified, and we also got selected for DRDO Technology Development Fund and IDEX initiative. With this, we look forward to expand our presence in Canada, Australia, Sri Lanka, and Thailand. We have developed a young and dynamic core team and execution teams to help achieve the organizational goals. We strive to achieve the philosophy of growth at individual level and also at organization level. And because of this, we have leaders in our organization for day-to-day decisions.
Thank you all for your engagement during the corporate video segment. We hope you found it insightful. Now let us delve into our guiding principle, which are the foundation of our approach. At the heart of our operation, we value our cores, which guide us to take the decision. Our customers are not just clients, they are partners in our journey. As a team, we actively listen and collaborate to customize our solutions to meet their unique requirements. Our success is directly proportional to our satisfied customers. Having discussed our commitment to being customer-centric, let's now see another crucial aspect: innovation in integration. Innovation is in our DNA. We encourage our team to think out of the box, to challenge the situation and come out with the integrated solutions. The spirit of innovation sets us apart sets us apart in the industry in the changing market dynamics. Innovation and integration are not standalone. They are witness our unique culture. Our organization culture is not just a tagline. It is the fabric that binds us together. Step into the Instron Technologies and you will immediately sense that we are more than just a workplace. Our unique organizational culture is the backbone which fuels innovative approach, empower our people and create an environment where everyone grows together. Having explored our guiding principle that defines the core values, let us now turn our attention to how these principles translate into our strengths. One of the reasons why Instron Technologies make a difference in the industry because of our unique strength. We stand out at the preferred supplier for customers due to the solution focused on delivering return on investment and quick and efficient delivery. Our expertise across various fields with strong R&D team help us to gain 200 plus industrial solutions implemented. Teams provide customized end-to-end solution with robust IoT platform, and our reach is widespread with our valuable broad network, valuable partners. Let us take a closer look at our wide value partners and the wide value partners and the extensive install base that stands as a proof at the trust place in Instron Technologies. That strategic tie-ups and installation are not just numbers, that reflects a collaborative relationship we have cultivated. Instron Technologies having a global presence with installation is more than 6 different locations worldwide. Our strength lies in having valuable partners in the different cities, which helps to widespread reach and service our customers. Our plan to have 40 plus value partners across the globe. These partnerships and installations not only reflect our capabilities, but also set a stage for why we stand as a reliable partner in the eyes of the clients. Instron Technologies is your dependable partner for implementing pilot plants, skids, automation solutions, motor test bench systems, and IoT solutions in the industry. We don't just start projects, we finish them with the impactful results. Our innovative automation solutions are designed to boost overall productivity, operational efficiency, product quality, and of course, equipment safety. We are reliable and has a proven track record which delivering 200 plus industrial applications. Key reasons for our success is rooted in the process expertise, focused need analysis, and in-house development. Strong vendor relationship help us to delivering the project in time. Flexibility in approach, low maintenance cost after installation, and sustainable solutions, they derive the customer satisfaction. Our IoT platform Planton, which is a proprietary platform developed by Instron Technologies, which is smart and designed to service our customer, which makes the solution scalable. Our extensive customer speaks about our success, projects, completions, and project expertise, which proves our values in the market.
With this, I would like to conclude this session. First of all, thanks to Dr. Deoras for taking out the time from your busy schedule and attending this webinar from the university. Thank you, Rahul, Rohit, and Dhanajay. And thanks to all the participants for asking the questions and taking out your time to attend this webinar. I hope we will interact with many of you for any of your immediate or future needs. And we look forward to meeting you in our next webinar series, which is a regular event at Instron Technologies. Every quarter, last month, we come up with an interesting topic. Okay. So thank you all. Thanks a lot. With this, we can now conclude this. Bye-bye and have a good day.
Thank you.
Thank you, everyone.
Thank you, everyone.
Thank you. Thank you.
Thank you. Thank you, sir.
Thank you.